Yeah, thank you. So, hi everyone. So, welcome to this unsupervised learning series. So, my name is Nikhil Narayan, and as Vivek told, I'm an AI intern slash researcher at Cellstrat. So, a few words about Cellstrat for people who don't know. So, Cellstrat is one of the prominent startup in the field of AI, focused on research and development in emerging areas of AI, ML, and DL like graph neural networks, reinforcement learning, advanced NLP, artificial general intelligence, etc. So Cellstrat is also focused on creating a dent in the healthcare sector with the help of AI. So the product team at Cellstrat has developed some really innovative solutions for healthcare. So if you have not checked that up, you might want to take a look at it on the Cellstrat website. So that's about it. So let's get started. Okay. So in this series, we are going to cover a lot of interesting topics. This series is aimed at introducing people to unsupervised learning and also exploring and deep diving into the uncharted territories of unsupervised learning. So that's how I like to put that. So we'll be covering some good topics. Like we'll start today with an introduction to unsupervised learning, and then in the coming weeks we'll cover few clustering algorithms, association algorithms, few Gaussian mixture models, uh, anomaly detection. So we have some good algorithms under dimensionality reduction and component analysis, which is again a very interesting and useful topic. So from 8 to 12, all of these come under unsupervised neural networks. So you have some really interesting algorithms under unsupervised neural networks. So this from 8 to 12 is also something which I'm personally looking forward to see where all we can apply the unsupervised neural networks along with also the other topics. So for today, we have an overview of what is machine learning, different types of machine learning. Then uh, we'll stack the different machine learning algorithms one against the other to see what are the key differences. Then we'll look at some types of unsupervised learning algorithms. Then we'll see the applications of unsupervised learning. And finally, we'll end it with what are the advantages and limitations of unsupervised learning. Feel free to ask questions in the chat. So I'll try to answer, if not all, most of the questions at the end of each section. Okay. So yeah. So this is the most common definition of machine learning, which says it is the study of computer algorithms that allow computer programs to automatically improve to experience. See, this is very different from conventional programming, where we hardcode the required steps to solve a particular problem. And that kind of an approach works for a easy to moderate kind of problems. But when you have a very complex problem like here, where you have to classify the images based on different classes, like for in this example as cat and dog, or for example if you want to a robot to do certain tasks, for these kind of problems, using a conventional approach would be very difficult because there are a lot of steps, and writing all of those steps would be very cumbersome, or you can say uh, you will not be able to generalize the problem. So in these kind of scenarios, the best way would be to allow the computer itself to come up with the efficient technique to solve these kind of complex problem. And this is what machine learning is all about. So as the name suggests, the machine will learn through experience to solve a problem. So we just need to pass the information to the machine learning model, or rather we need to expose the machine learning model to through variety of experiences in the form of input data. Here we have three most common types of machine learning algorithms: the supervised learning algorithm, the unsupervised learning algorithm, and the reinforcement learning algorithm. Apart from this, you also have something called as semi-supervised, which is a interjunction of supervised and unsupervised. Since it's a combination of these two, I've not put it here, but we will probably discuss it later. Okay. So now let us look at each of these three machine learning algorithms one by one. So the first one is supervised learning. So in supervised learning, the task of any supervised learning algorithm is to learn a function that maps the input to the output based on the input output pairs of a training example. So what does this mean? So here what we are asking the supervised learning algorithm to do when we train that particular algorithm is we are asking it to come up with a connection between the input and the output, right? We want to connect the input to the output. So what is this connection? This connection is in the form of a function, right? So to clarify this, let me take a simple example of a linear regression problem. So let's say we have the house price versus the area of the house. Okay, so as the area of the house increases, the price also increases, right? And here are the data points. So if I have to fit a line through this, I'll fit a straight line since it is following a linear path. So in this kind of problem, uh, if I want to predict what will be the price of the house for a certain square kilometer, certain area of the house, then I will do a linear regression problem. So if I break down the linear regression problem, it is a simple equation which will be something like this: y is equal to wx plus b, right? So here in training, we know the output y and we know the input x. So what does the system have to learn now? It just needs to learn the weights and the bias. Okay, so this weights and bias together with the input will act as a connecting as a connection to the output. So that is what this means. So this can be generalized to classification problems as well, where you have, let's say, an image of a dog there and or a cat, and then you want to identify it as a dog or a cat. Then what you are asking the system to do is learn the weights and biases so you can correctly classify them as dogs and cats. Okay, certain images. Then the second point is the term supervised is used because the learning process from the training dataset can be thought of as a teacher supervising the learning process. So in the previous slide, I just told that the system is going to learn on its own through experiences, right? Then where is the supervision coming from? So then where does supervised learning require our supervision? So think of this as an analogy. What I can give here is, think of this way: a kid goes to a school, and the teacher there shows a picture of a cow and tells the kid this is a dog. Yeah, she shows a picture of a cow and she tells this is a dog. A very exaggerated example, but so the kid learns this, and while he's going back home, he sees a cow and he tells that it as a dog. So what we do, we blame the kid because he's telling it wrong, but the matter of the fact is he has been taught wrong. Yeah. So similarly, when we train the machine learning model, you can think of the machine learning model as the kid. Okay, so when we are teaching that model, we need to be very careful about what we are teaching it. We need, for example, when we are classifying, asking the machine learning model to classify it as dog and cat, we need to make sure that we have labeled the dog images as dog and cat images as cat, and we have not mixed it up. Because if we mix it up, then the machine learning model is going to learn the same way, and when you test it, it's going to give out the wrong results. And then you should not blame the model for that, because it's our responsibility to feed the right input data. Yeah, so we need to be very, very responsible with the what we are feeding to the machine learning model. So this not only refers to labeling of the data, but also all kinds of EDA, right? all kinds of exploratory data analysis can be thought of supervision from our end. So for example, let's say we are doing a linear regression problem or a logistic regression problem, then we assume the data distribution is somewhat normal, right? A Gaussian distribution. But if our data is somewhat skewed, okay, as here, and then we use this data to logistic regression, then we cannot expect a good result out of it because it's not following a Gaussian distribution. And the fundamental principle of or fundamental hypothesis of linear or logistic is that the data is distributed normally. So we have to take into account of uh, what the certain algorithms can do, what are its hypotheses, and to make that algorithm efficient, what all steps we need to take in terms of correcting the input data or cleaning the input data. So all these terms, all these steps come under our supervision, right? That is the reason why it's called supervised learning, because the machine learning model cannot do everything on its own in this scenario. And there is certain a step of pre-processing required before the model actually starts learning. So that is the second step, right? Then yeah, so the third point is supervised learning methods assume that labels are available for all training samples. So as I told before, I think it's pretty much understood that in supervised learning, the labels of the input data, all for all the input data should be available. Okay. The fourth point is very important. In supervised learning, it intends to infer a conditional probability distribution. So what does this mean? So in terms of classification problem in supervised learning, we say that it tends to infer a conditional probability. Okay, without going in depth math about conditional probability, let me just briefly explain what conditional probability is all about. So let us imagine we have a sample space S, and we have two events A and B, right? So in this case, it is independent of each other. But if a scenario exists where event A and B are dependent on each other, then we cannot look at the probability individually, okay? Because then we'll have to look at conditional probability. Okay, let me explain this with an example. So imagine you are traveling from Bangalore to England through Dubai. Okay, so you have a connecting flight in Dubai, and you have to catch a flight from Bangalore. You have to go to Dubai, and from there to England. Now I will define two events. Say event A is the probable event is let's say missing my connecting flight. Event A is missing my connecting flight. Okay, and event B is the current flight getting delayed. Sorry for the writing, but hope you understand. So current flight getting delayed. So there are two events. So event A is missing my connecting flight, and event B is my current flight, that is from Bangalore to Dubai, getting delayed. Now I will say the probability of me missing my connecting flight is 0.6, and the event or the probability of the current flight getting delayed is 0.2. Okay, now if I want to know what is the probability of me missing my connecting flight, I cannot just look at it as 0.6, isn't it? Because it is somewhat related or closely related of the current flight getting delayed. So then we need to ask ourselves a question: what is the probability of me missing the connecting flight provided my current flight get delayed? So that becomes a conditional probability. Yeah. Now now I explained this conditional probability, but then where is this used in machine learning? So let's say I want to know if a patient is diabetic or not. Yeah. So that becomes my y, the output. If a patient is diabetic or not, yes or no. And then I have a lot of variables like x1, x2. Let's x1 be age, right? And x2 be a parameter called whether there is someone in my family having diabetes already. Then the chances are I'll have there is very good chance of having diabetes, right? So in this case, y is whether the patient is going to have diabetic or not is the output, and x is all these parameters. So what is the probability that I can have diabetes provided these are the input variables? So then that becomes a conditional probability. So in supervised learning, we always look at this conditional probability because we are always looking at if the input data is so and so, what is the outcome y? Yeah. So I hope this point is clear. Then next point, yeah, this is again a very important point in supervised learning. So supervised learning needs good examples from each class. For example, in image classification problem, what I told earlier, if I have lot, if I want to classify as cats and dogs, then I need to have lot of images of cats and dogs. Yeah. Then the another final point here is the decision boundary might be overfitted to the training set if the model is tightly trained. So what this means is again refers to is closely related to the previous point. If I train it with very few examples, okay, then the chances that the machine learning model generalization of the machine learning model is very low. So it will just detect the images what you fed in the training. It cannot detect the images which you have not shown during training, and you don't want that to happen, right? You want the model to be as generalized as possible. So you train them on certain data set, but when you feed uh, a unseen data set which is similar to the training, it should be able to give the uh, correct prediction. Okay, let's move forward. Okay, moving to unsupervised learning. So unsupervised learning, as the name suggests, does not require any explicit supervision, right? Like for example, when I told in the previous scenario that we need to ensure that data is clean and it's labeled properly, etc. In unsupervision, that is not required. Okay. So what unsupervised learning algorithms do is basically they try to find hidden patterns in unlabeled data. Yeah. So irrespective of this unlabeled data is clean or not, whether unlabeled means no labels basically, so it can find hidden patterns with minimum human supervision. Okay. Then another point about unsupervised learning is that it can be further classified into parametric and non-parametric unsupervised learning. Mm, okay. I I would like to say that this classification of parametric and non-parametric can be applicable to both supervised and unsupervised, but I thought it would be convenient to bring this topic here in unsupervised learning. So let me explain what parametric and non-parametric unsupervised learning is all about. So to put it in simple terms, a parametric algorithm will have a fixed set of parameters irrespective of the increase in data set, whereas in non-parametric models, the parameter increases with increase in data set. Okay, it can even have infinite number of parameters. So uh, for example, okay, here I'm going to take example of a supervised learning algorithm. Let's think about a linear regression problem. Yeah, this is the fundamental equation of a linear regression problem. So irrespective of my input data x being small or large, the only parameters the model has to learn is just w and b. So it's fixed. Yeah, it's fixed and it's very rigid. Whereas if you look at unparametric or a non-parametric learning, for example, if you take a classification problem like using a KNN model, it does not have anything, any form of a mapping function like this, right? It just tries to find patterns that are close and are likely to have a similar output. So this can be thought of as a non-parametric unsupervised or non-parametric model or a non-parametric algorithm. So any questions on this? Because it's a very important topic, the parametric and non-parametric. Okay, I would feel free to ask me questions if you get any doubt. Okay, I'll just move forward. So if you want to take examples of parametric and non-parametric models, so parametric models example are linear regression, logistic regression, perceptrons. In a parametric non or parametric unsupervised learning example is a Gaussian distribution model, a Gaussian mixture model. And a non-parametric unsupervised learning model can be thought of a k-means clustering algorithm is an unsupervised parametric model. Okay, I see some questions. Let me. Okay, what is there's a question here. What is parametric UL? Sorry, what is UL? Okay, what is parametric unsupervised learning? Okay, so here in parametric unsupervised learning, what it means is that there is no fixed number of parameters uh, parameters required to do the classification, right? For example, if you think about a Gaussian model for classification, you know that it's normal distribution. You have a parameter, say mean, right, and the standard deviation. So these parameters remain fixed irrespective of the how much the quantity of your input data is. But if you're doing a classification problem with the help of say something like k-means, yeah, or a KNN, then it does not have a fixed set of parameters like I told you here, or in the linear case, a linear regression case. So that tends to vary depending on your quantity of your data or the variety of data what you feed. So these parameters keep increasing. So that is also one of the reason, if you have observed, if you have solved a SVM or support vector machine, which is also a non-parametric unsupervised learning model, if you have solved that, you will see that those kind of models take very long time to compute compared to a parametric model. Yeah, so so one advantage with parametric is it is simple and it's computationally efficient compared to non-parametric models. But the disadvantage of parametric models is that it's very rigid. Yeah, it cannot generalize too much, or it cannot take too much variety of data, if I put it in simple terms. So that is parametric and non-parametric. Again, parametric and non-parametric is applicable to both supervised and unsupervised. So don't get confused with that. The next point, unsupervised learning intends to infer a prior probability distribution. So in previous case, what I told was it was a conditional probability, right? Again, based on the Bayesian uh, probability theorem. So here, if I say, if I take an example of a Bayesian model, and I say P of y slash x, which is the posterior. Then this is the product of likelihood into prior probability. Yeah. So what is prior probability? So in prior probability, you actually, since in unsupervised learning there's no labels, right? Why? So you just need to assume certain probability while solving the problem in the initial stage, because there is no definite probability. So in prior probability, like there's no definite probability like you saw here. Given x, what is the probability of y? Because here there is no y, then you would just assume that a certain model, a certain object falls into this category. So you are making an assumption. So you only know the range of the probability, but you don't know the actual probability of a certain object falling into a certain class while doing the classification. That is the meaning of prior probability. So most of the unsupervised learning will infer a prior probability, not a conditional probability, because we don't have any labels why. Okay. And another point is unsupervised learning can work with real-time data. So since we don't need to do any kind of data cleaning or data labeling, we can use the data as it is in a real-time scenario. So that's one of the biggest advantage of unsupervised learning. Okay, moving to the next one, reinforcement learning. So in reinforcement learning, the objective is to master a certain task based on rewards associated with the actions taken by the agent. So let us think of a scenario. Let's think of certain, sorry, yeah, let's think of a maze. Yeah, and imagine you have a toy car here, or let's say an unmanned car. So you're not controlling the car. So you have an unmanned car. The objective of this car is to reach here, reach its destination. So when it starts, okay, it might hit these ends and then it can get stuck here. So it will reach, finally it will reach at this location using trial and error method. So this can be thought of a reinforcement learning. So here what you are doing is you are giving rewards to this agent. So in this case, the car can be thought of an agent, and this puzzle, what you're seeing, is called as the environment. Okay. So if it moves correctly without touching these borders, then you can give a positive reward, okay, saying it to follow that particular route. But if it gets stuck somewhere, then you give it a negative reward. So as soon as it gets a negative reward, it understands that this is not something it has to do, and this is not the path it has to follow. So using this trial and error approach, it finally reaches this end goal. So, and another term associated with reinforcement learning is, apart from agent and environment, is actions, right? Actions. So what are the actions this agent can take? So let's say it can move straight, it can move back, it can move left, it can move right. So these are the actions. So using these actions, the agent explores the environment and tries to reach its end goal. So as I told, the reward what is associated with to the agent can either be positive or negative. So positive says the action is successful, and the negative reward says the action should not be repeated. So it can do this in n number of iterations, right? In the first scenario, it gets stuck multiple times and it reaches here. In the second iteration, it does fairly better. In the third iteration, it does even better. So the agent analyzes different configurations of the environment in various iterations, and it tries to find a policy. So what is this policy? So policy is nothing but, in this case, you can think of it as an, what is the most efficient path it can take to reach this end goal without getting stuck somewhere, right? So that would be the task of a agent in reinforcement learning. So it has to finish reaching this end goal, but remember, we are not doing any kind of supervision here. We are only giving rewards. Yeah, we are only giving feedback. So it's very different from supervised learning. Or uh, and and it has to find an optimal policy, and that could give a high reward. So see, what does this mean? Expect maximizes the expected total award. What does this mean? It means that, see, if it goes or reaches the end goal without touching these borders, it means that it has a lot of positive rewards, right? And if it has positive a lot of positive rewards, it means that the total reward is at maximum. I hope it is clear. So that is what uh, the task of agent in reinforcement learning is all about. Okay, so we finished the first section. So let me see if I have some questions. Okay, no questions. Audience, any questions? Uh,
Yeah, maybe this was answered, but what is parametric UI? Maybe you answered it. I might have missed it.
yeah, it's parametric UL. It's parametric unsupervised learning. Yeah, I answered that. Yeah,
Okay. So no further questions so far.
okay, fine. So let's do a one-on-one comparison. So we'll stack supervised learning, unsupervised, and reinforcement learning here. So what are the types of problems solved in supervised learning? So basically two major problems. One is the regression problems and the other is the classification problems, which I explained a little earlier. Then in unsupervised learning, you have something called association and clustering, right? These two are the most important or most common type of problem solved in unsupervised learning. So what is clustering? So we'll look at what is clustering and what is association in the coming slides. But remember that for now, that in unsupervised learning, the most common problem solved is association and clustering. So in reinforcement learning, as I told before, you are uh, giving an agent a set of action, and it has to find the optimal policy that maximizes the reward. So in this case, you can see a computer playing a chess game. So that can be thought of a type of problem solved in reinforcement learning. Or a robot trying to solve a specific problem can be thought of a reinforcement learning problem. And what are the types of data used, right? In supervised learning, you have labeled data. In unsupervised learning, you have unlabeled data. And in reinforcement learning, you actually do not have any predefined data, because you are just defining the environment, the agent, and what actions it can take, but not any specific kind of a data. So what are the training or learning approaches each model takes, right? So in supervised learning, you have the labeled input and the corresponding output, and the task is to map the labeled input onto the corresponding output. In unsupervised learning, the objective is to identify the hidden patterns as output. Here, there's no question of mapping, because you don't know what is the corresponding output for the given input. Yeah, in reinforcement learning, as I told before, it's all about trial and error. So the agent tries to find the optimal solution by trial and error approach. Okay, then what about feedback loop? So in supervised learning, you can think as error function as a feedback loop. So you know the input and you know the corresponding output, and if there is a difference in prediction, you can calculate what is the difference, and you can send that as a feedback to the model, so that it can correctly it can readjust the weights and biases to find the corresponding output. So for example, mean squared error can be thought of a feedback loop for supervised learning. So in unsupervised learning, definitely, as you all know by now, that there's no feedback loop. In reinforcement learning, you can think of reward as a feedback loop, because with the help of reward, you are telling the agent what is the most optimal uh, approach to solve a particular problem. Okay, moving forward, what are the types of unsupervised learning algorithms? So here I have basically classified them into four groups. You can see here. So one is clustering. So under clustering, you have various algorithms like k-means, k-means plus plus, k nearest neighbors, spectral clustering, then density-based spatial clustering applications with noise. Then you have hierarchical clustering, Gaussian mixtures, etc. Then you have association problems where you'll be looking into a priori algorithm, LCAT, FV growth, etc. Then you have various algorithms under dimensionality reduction like PCA, single value decomposition, the LDA methods. Then you have certain neural networks, unsupervised neural networks to be very precise. Under them, you have autoencoders, the PCA, GAN, self-organizing maps, and unsupervised deep belief networks. So let us look at what each of them mean here. Okay, clustering. Clustering can be thought of grouping a set of objects such that the objects belonging to one group are more similar to those in the other groups. Okay, what does this mean? So let's take a problem statement. I feed the unsupervised learning model different types of fruits and vegetables. Okay, say apple, oranges, uh, maybe carrot, etc. And we say these unsupervised learning model to classify them. So what it does is it might cluster them based on shapes, and or it might cluster them based on color. We don't have any control over that. That's one of the disadvantages of unsupervised learning. But since you don't know anything about the data, clustering would be a good approach to get to know the data. So so that is clustering. What is association? So association is a descriptive method where you are using it to discover interesting relationship between hidden large data sets. So in association, can the best example to give you would be of Amazon, right, or any websites, e-commerce websites. So if you buy a certain product, or let's say some grocery website, you go and buy milk, yeah, and then when you buy milk, there is a very good chance that you might want to buy bread and butter for breakfast, right? So these association models study these relationship and they recommend products to the customers. So in most in recommendation systems is mostly based on association. Okay, then you have something called a dimensionality reduction. So what is dimensionality reduction? So it is nothing but transformation of data from high dimensional space into a low dimensional space. For example, let's say you want to visualize a certain data, okay, a certain set of parameters and its dependencies. The maximum dimensions you can visualize that is in 3 dimensions, right? Three set of parameters or three set of variables. But if you have like n number of variables, then how do you visualize them? How do you find a meaning in that data? At that time it becomes very tough, right, to visualize that data with n dimensions. So what you have to do is you have to reduce or transform that data from high dimensional space into a low dimensional space, but at the same time you're also not trying to lose too many properties of the original data. With that and keeping that in mind, you will be able to visualize these complex data much more easily and get some meaningful insights out of it. Then the last is the neural networks. So I think most of you would be familiar with neural networks if you have worked with supervised learning. So it's nothing but a computational system inspired by biological neural systems. Okay, nothing but collection of nodes called artificial neurons. So if you have like these nodes which are interconnected to each other, something like this. So you feed the input, yeah, and you get the output y as a probability. So these are used to solve complex machine learning problems such as image recognition, NLP, etc. Okay, so let me see any questions.
Audience, any questions here? So I guess we are good. You can continue.
Okay, okay. So moving forward, yeah. So what are the applications of unsupervised learning? So clustering, as I told before, can be used to split data set into groups, right, based on their similarities. So it can be used in variety of places, this clustering. For example, okay, you can use unsupervised learning to see how the data looks before you feed it to a supervised learning model. So like you can randomly, without labeling or doing any data cleaning, you can just feed it to some unsupervised learning model and see how the unsupervised learning model classifies them. If you don't have any labels, you can just see what ways you can label it. So that can be thought of, that can be a good example where clustering can be used. So as a first hand view, you want to see how the data looks, you can use unsupervised learning, and then process the data and feed it to supervised learning. Okay, then the next example is unsupervised learning can be used for finding fraudulent transactions. So if you this is used in to detect any wrongdoings in credit card transactions, right? So it has the ability, you can use certain unsupervised learning algorithms to detect uh, anomalies or fraud transactions, etc. Fine. The third point is it can be used to detect anomalies in machines for predictive maintenance. Okay. See, this is something I can relate with very closely since I am from a mechanical background. So I work for a wind turbine manufacturing company. So there, you have these wind turbines placed in sea. Okay, these are called as offshore wind turbines, and the life of this wind turbine is 25 years. So once it gets commissioned in sea, it has to have a life of 25 years. So one of the main components in this wind turbine, when this offshore wind turbine, is the something called as bearing. Okay, we call it as main bearing. So here the bearing is used to transfer smooth rotation of the components. So if something goes wrong with this bearing, it is a big challenge to exchange this bearing, put a new bearing into this. It would cost somewhere about 3 to 5 million euros to exchange one bearing on one single turbine, because you will have to go in an offshore, you will have to go in a ship with the component, because these are not small components, it's a very huge components. Okay, then there will be downtime because you cannot run the turbine, there's a loss to the customer, etc. So to ensure that there's nothing going wrong in the bearing, there are a lot of sensors. Okay, there are what we call as health check monitoring systems. So inside health check monitoring systems, you have various sensors, like you have a vibration sensors, temperature sensors, etc. Now if you take the data out of these vibration sensors and temperature sensors, and it can have varying data. Okay, the vibration can be varying with different wind speed. Okay, as wind speed changes, it can vary, and similar to temperatures, as the wind speed varies, the temperature inside the turbine can vary for various reasons. Okay, but but those are since it's varying does not mean there is something wrong with the turbine. Okay, it's because the wind speed is varying, that's why these parameters are varying. But if something wrong goes inside the bearing, let's say there is something wrong with the lubrication inside the bearing, then the temperature really shoots up. Okay, It provides something different from the normal behavior. Okay, now in this case, you cannot collect the data and you cannot label the data and you cannot train the data. You want real time feedback. Okay, as close as soon as possible, as early as possible. You want real time data, a real time detection. So in these cases, you can go for unsupervised learning algorithms. Another example would be if any of you are from aerospace background, you can say that again, aerospace components are the safety margins of aerospace components are very high, because it's a risk to people. So they do a lot of these analysis on these components. They record a lot of sensors on. They put a lot of sensors on this aircrafts, and they constantly monitor the health of the aircrafts. That is one area where you can use unsupervised learning. Then, okay, another place is again in healthcare industry. Why not? You can still use unsupervised learning to see whether the the health parameters of a patient is something very different than normal or not. So you can, for all those cases, you can use unsupervised learning. Then, as I told before, the recommendation systems. So yeah, so I was giving you the example of e-commerce, right, where it can help the customer select the right products. In fact, it can recommendation systems trick you to buy the products, if you look at it, uh, based on the popularity, etc. It can be used in medical imaging for distinguishing between different kinds of tissues. Yeah. So if you don't know the labels, you have a lot of data. You want to just differentiate them between, say, cancerous or a non-cancerous tissue. Uh, then you can use unsupervised learning with reasonable accuracy. Then in market research, it's definitely used in market research. Let me take an example here. Okay, let's imagine that you are owner of a telecom industry. Okay, and you have a lot of customer information. Let me put call on the x-axis and let me put data on the y-axis. Data is nothing but internet usage. Okay, and you find certain clusters here. Okay, so this person is using low data and low calls. This person is using high data, sorry, low data and high calls, and this person might be using low calls and high data. So if you want to retain all these customers, you cannot give them one single plan. Yeah, so you want to give them plans such that they it caters to their specific needs. So how do you do that? So from this classification you can see that this guy needs more data. Yeah, more data offers. It does not need much offers on calls, whereas this person needs more offers in terms of calls. He's someone who calls a lot and uses internet less. Maybe because of age group also. He might be very old. He's not too much accustomed to internet. He only uses the phone for calls. So you can do this kind of market research using unsupervised learning fairly easily. Then it is also used in biology for genetic and species grouping. Okay, let me see if there are any questions. Okay, can you explain dimensionality reduction again? Fine. So, okay, what we are doing in dimensionality reduction is basically, okay, let's say, yeah, let's take a scenario where you are visualizing the dependency of several inputs. Okay, there are four parameters: x1, x2, x3, and x4. Now, when I put them onto a graph, I can put only three dimensions here. Now, what happened to fourth dimensions or fifth dimension and so on? Then how do I know what is the relationship of this, or what is the what is the effect of this parameter on the output? How do I visualize that? I cannot do that, right? And it does not mean that there are only four parameters. It can have n number of parameters. So in that key scenario, when you want to visualize what is the effect of certain parameters on the output, you would like to pick uh, the parameters which are most influencing the output. Again, let me put it that way. You just want to pick up parameters which are most influencing the output, and the rest, the influence might be very, very low. So in that case, let's say in this case, it's only x1 and x3 which is mostly influencing the output. Then you can eliminate, or you can, their influence is very, very low, and then you can reduce into just a two-dimensional problem, and you can see what are the influence of only x1 and x2. So that is a simple example of a dimensionality reduction. Okay, fine. There's one more question. Is there no feedback at all in unsupervised learning? I suppose. No, there is no specific feedback as such, but you have various uh, parameters, or you have various you have various parameters to check whether they give how good the output whatever it has given, the unsupervised model has given us. Like, is it relevant, or is it too good, or is it too bad? But it cannot, it cannot learn, it cannot correct itself like supervised learning, where you have an error function and it readjusts the weights and biases, etc. No, the unsupervised learning cannot do that. Fine. So the advantages and limitations. So one of the big advantages is that, yeah, does not require large amount of data, like supervised learning, where you need to have a lot of images of certain class. So this is comparatively to supervised learning, you don't need large amount of data. And as I told before, it has the ability to work with real-time data. Not much of data cleaning is required. And I also explained certain examples where you can use the real-time data and the unsupervised learning to get some meaningful outcomes. Yeah. Then clustering, again, to gain some insight into structure of the data before designing a classifier. Yes. So as I told before, you can use clustering to gain some insight into the data. Then probably you can decide whether to go to unsupervised or supervised. Yeah. So what are the limitations? So these are the two most common limitations in unsupervised learning. So since you don't know what the result is, since there is no labels prior to the output, prior to the test, or prior to the model giving you the results, you don't know how the result should look like, right? Because you have no information about the outcome. Then you will have to spend a lot of time interpreting the results given out by the unsupervised learning. So that is a big drawback. Then the other one more is that it lack of full insight into how or why an unsupervised system reaches its results. So this is also a problem because you don't know the exact steps it has taken to reach the results, or why it has reached its results. Yeah. For example, I was giving you the example of classification of vegetables and fruits. So it can classify based on shapes or colors, etc. So you don't know why it did it using shapes or colors, right? You don't have any control over it. So that is also one of the limitations. Okay, let me take few questions. So there's a question whether wind turbine uses AI right now. Not specifically, not. There are a lot of data analytics going on right now in wind turbines, but still it is in a I mean, there are a lot of data analysis going on, but I would say when you say AI, it's very broad. So can you be more specific? Then I can say whether it is using. whether wind industry is using AI or not. So yeah, they are doing some sort like they have to do some sort of data analysis to see whether a wind turbine can be erected in certain regions or not, whether the wind speed is sufficient for wind speed is sufficient in that region, or will the wind turbine give good output, good electricity at that particular region. To analyze all this, you again need some sort of data analysis. Yes, so that the wind industry is deploying. Okay. So yes, so coming to the conclusion, yes, so this was fairly basic introduction to unsupervised learning, or this was a session just to get ourselves familiar with what unsupervised learning is and how different it is from supervised learning. So we learned about different types of machine learning algorithms like supervised, unsupervised, and reinforcement learning. So in supervised, we came to an understanding that it needs to learn a function that maps input to the output, right? This example. So mapping a function, so it has to learn the weights and biases. In unsupervised learning, it looks for hidden patterns in unlabeled data. And in reinforcement learning, objective is to master a certain task based on rewards. Then we looked at what are the different types of machine learning different differences between the three machine learning algorithms in terms of problem solved, the type of data used, the learning approaches, and the feedback loop. Then we also looked at what are the different types of unsupervised learning algorithms. So they are broadly classified into clustering, association, dimensionality reductions, and neural networks. We also saw the various algorithms under each one of these. Then finally, we also looked into the advantages, limitations, and application, certain applications of unsupervised learning. So yeah, that's about it for today. So if you have any certain questions, you can ask. Okay, I don't see any questions.
So any
Hello,
other
Vivek.
questions for today? Yes, I'm here. So any other questions for today, folks? So that was a very crisp and clear explanation of basics of unsupervised. And this is the first of the webinar series, so hence there is no coding demo. But if you notice the TOC, a lot of advanced topics are coming up, things like autoencoders and various kinds of clustering techniques, and there are other topics like GANs and SOMs, and so it's a very sophisticated area, and the upcoming sessions will cover one by one. So it's much harder, by the way, than supervised learning because the Y level is missing, as you can see. So you have only limited capability, and you try to get some data insights from unsupervised data. So any other final questions or comments? Any feedback for Nikhil here? Okay, so some good feedback is coming on the chat. Thank you to Nikhil for arranging this session and preparing very crisp and clear content. And with that, in interest of time, we come to an end of this session. Thanks audience for joining, and thanks a lot, Nikhil, for preparing some excellent content and very nicely explained, as the audience is also attesting in the chat.
Yeah, thank you all for attending. So yeah, looking forward to the next session where we will be covering clustering. So you can expect a demo there, and we will solve some good problems in clustering. So once we finish the basic clustering, then the coming weeks we'll have also some advanced clusterings, which is not well versed with people may not be well versed with. So you might want to attend that as well. Yeah. So thank you all. Have a good day and have a good night.
Thank you all.
Okay. Thank you, Vivek, for the opportunity. Yeah.